let's start to build our time value of money toolbox. So what are the equations, what are formulas we're going to need to be able to convert cash flows over time? Let's start with the basic, the very simple example. A lot of our examples will be about saving a bank account, earning a certain interest. This is not the most interesting application, but it's one of the most obvious, one of the simplest basic sort of setup. So we can use that. It's a time value of money problem because you deposit a certain amount and then the value in the account changes over time, right? You're being compensated for depositing your money, it's earning certain interest, and then the value grows over time. So that's sort of a basic time value of money application. So if we start with baby steps, so let's imagine $100 earning 2% per year, right? So what will happen? What will happen is, let's have our timeline. It's not really necessary. This is very simple, but it's nice to demonstrate visually what's going on. So we have today, we are making a $100 deposit, right? And we have 2% interest rate. Remember, we put our interest rate on the top left next to 0. And then in 1 year, right, what we're going to have is our $100 will have earned 2% interest. So we'll have grown 2%. And the way we write this is, or the way we calculate this is, in 1 year, we're going to have $100 times 1 plus the interest rate, percentage converted to decimal, when we are doing our calculations. So this is how much we're going to have in the account, right? $100 times 1 plus the interest rate, 0.02. So 1.02 times 100. So we're going to have $102. That $2 is our compensation by the bank for the time value of our money, that we are depositing this. We don't have access to it during that 1 year. They have access to it. They put that $100 into productive use. By lending it out, they earn, at least in theory, and a lot of times in practice as well, more than a 2% return using our $100. So they give us back 2%, and they keep the rest. The rest is their profit, right? So we have now $102. So this is what we call simple interest. And the way this works out is, when we are building our equations, we're going to think of this as our PV, right? So our present value of our money. And here we are trying to figure out its future value. So you can think of this as the FV, future value. And this is our interest rate. And this, in this case, in this simple example, is our N, time. Okay? So we have the simple interest case. We end up with FV equals the amount we deposited times 1 plus I. So simple stuff, right? So now, though much more interesting and relevant to us for our more complex cases going forward, is compound interest, meaning that we don't stop here, right? We don't have 1 year horizon. We have multi-year horizon, sometimes very, very long, sometimes even infinite. So we need to extend this to, say, year 2. So, and assume that we don't touch this amount, $102. We don't take like the interest or even a bigger portion. We just leave it in there. So the amount now, the $102 will earn interest itself. And let's assume that the same interest rate applies, so 2%. So our $102 earning 2% itself. What will that look like? Well, we have this amount, $100 earning 2%, then earning 2% interest itself. So now it's going to be 100 times 1 plus 0.02 times 1 plus 0.02, right? So 2% interest twice, okay? So if we generalize this, by the way, this is going to be, so $102 earning 2%, so 102 times 1.02, we end up with 104.04. So we didn't just earn $2 interest. So we didn't just get to 104 like we did in the first period, right? We earned $2.04. Where is that extra 4 cents coming from, right? That's compound interest. That extra amount is the interest earned on the interest from the first year. That $2, so $100 earned another $2, but the $2 from year one earned 4 cents. So we ended up with $104.04. So that amount, the compound interest, doesn't seem much because we are talking about a very low interest rate and we are talking about just one extra year. But then over long periods of time, that compound interest idea, so that will really kick in and numbers will be much greater. The effect will be much greater. All right, so this was simple interest. So let's generalize this. Let's not step in 2 years. If you go further and further, where do we go? Where we go is compound interest will give us future value, so say the amount in the deposit after, say, n years, so because we are generalizing, n can be 1 to anything, right? That's any large number. A future value equals the present value, so the single cash flow that's deposited, earning I interest over n years, right? So this is squared, 1 plus 0.02 squared. So after 3 years, we're going to have 3 terms, so it's going to be cubed, so on and so forth. So that n enters as the exponential in that formula. Okay, so that's compound interest, and that's a very, very critical formula for us that will apply to many different time value of money problems, not just money invested, deposited in an account. But then it's also going to be important in the sense that now that we know this, we know how to find the future value of money, we can actually work backwards and find the present value. All right? So we'll talk about these a little bit in the next video.